laptop, computer, share screen, iPad. And someone did ask me if it's a Dell. No, it's a Lenovo. I've never used a Dell laptop. I don't know why. I have this very strong affinity with Lenovo. All of my laptops since day one has been Lenovo. So all the Windows laptop has been Lenovo.
ThinkPad?
No, not ThinkPad. This time I went for Slim because I wanted a very long battery backup. Because anyway, all the development is like offloaded to cloud, so you don't have to spin up a lot of heavy stuff locally. So a good battery backup with a basic gaming support is what I was basically what I wanted. I just went for Slim Yoga Slim 5i or 7i something. And basically, this was the best decision of my life to like not use office laptop. So basically, productivity shoots like 100x. Because office login nahi hai. If you don't use office laptop, so office laptop you have Slack and emails and whatnot. So no distractions whatsoever, like purely focused on work that you are doing. So this has been a great boost for me at least. Yeah. Uh, yeah. So for folks who don't know, I've just posted on Discord about a link called learn.relog.in. I'll also drop an email to all of you to basically requesting you to log in on that. Your account is already created. That is the learning management system that we'll be using. I'll be uploading videos on that. It will be uploaded to Vimeo and embedded on that website. And through that, you'll be able to access the content on all sorts of resolutions. It has taken care of transporting and stuff, and there you'll find agenda for all the future weeks. Zoom link is also there, so in one click you can like reach there. There is also an option to download the entire calendar invite. So since for this cohort the problem we saw was like a Google group email was not reaching everyone and calendar invite was a hassle. So solving all of the problem for in one shot, if someone wants to add it to calendar, you can download the .ics file and import it to your Google Calendar. For all the sessions, there is a detailed agenda. So not something that is there on my website, but a detailed one on the exact topics that we'll be covering. You'll find it there on the website. And soon I'll be planning to add quizzes, resources for all of them. Like for example, the kind of content that we are sharing on Discord and all of that part, I'll just add it over here, and few resources which are referred to, basically compile all the topics at one place. That is something that I'll add. Now, coming to the tech stack of it, a very interesting choice which I made was using DynamoDB. Again, it's a one-person company sort of stuff. So I don't really want to use a very proficient language like Golang, which might be really very efficient. But I wanted to improve on developer productivity. So I wanted to code this thing as fast as possible. So 3 days my backend I got up and running, hosted on AWS Lambda, not on any EC2 server, hosted on AWS Lambda, which is why the first request takes a little bit of time, because it is basically warming up my Lambda. But that's how it is, because I don't expect a continuous traffic on this, right? If I'm using an EC2 instance, EC2 instance is constantly running, which means I'm constantly build that particular amount, right? Unless and until I get continuous traction, it makes no sense for me to build to basically deploy it on an EC2 instance, right? So the entire deployment is done on AWS Lambda, connected to AWS API gateway, and basically which is then connected to my Route 53 domain, which means api.dugup.com. So basically, Dugup was another spare domain which I have. So api.dugup.com points to one AWS Lambda. That AWS Lambda has this Flask server running. So every time you make a request, this Flask server gets spin up fresh, and it basically handles your API request. So basically any request that you make. Number one. So this way, since the traffic is not going to be continuous, it is going to be bursty, which means the billing would be very optimal. I would only be billed for the usage that you guys make, and baki time I would not be billed at all. So that's a very big advantage. And for front end, I used Nuxt.js. I'm a big fan of Vue.js. So I've used Vue.js abstraction, which is Nuxt.js, which makes life a little simpler. So I use Nuxt.js, and for CSS framework, I've used Bulma. I've written some spare theme of mine and given it a dark look, like just for fun. Might change, you might see a very drastic change in next couple of weeks, as then when I add more features on the educator side of things. So yeah, that's front end. The back end deployment is done on AWS Lambda. Front end is hosted on Netlify because it's a static site. It's not a dynamic. So I don't really need a server to run this. Everything is static site. So every page that you load, if so for the first load, it would go to the server, to the Netlify server. And that's where I have pre-generated HTML content there. So every time the server loads, the pre-generated content does not really have anything. It's just a blank normal file which gets served. And what I've done it is once it loads, then the normal API call request actually takes care of the entire application whatsoever, right? So that solves my problem to not have server for this. So effectively, I'm only paying for my domain, which I just purchased like relog.in, having two CNAME hops because I want to create a B2B product out of it. Something I'm planning. If it works, it works. Otherwise, I ठीक है चलेगा तो चलेगा types. But yeah, effectively with only paying for the domain, I'm giving you guys access to a full LMS sort of solution. A very hacky solution, but it would work mostly for lifetime because like I'm not expecting a continuous traffic on this website anyway. If it happens, if I get a continuous traffic, then obviously I'll move to EC2. Otherwise, till that point, AWS Lambda runs. So that's what the tech stack of that site looks like. And if you're building something like this, always think about the most cost optimal solution for this. Like don't go for EC2s and all from day one because you don't know if you're getting traffic or not. If you're getting, then go for it. Otherwise, there is no need whatsoever. If you're booting up, then always go for a hackier solution to like, for all of this problem. I don't even have an S3 bucket yet. S3 bucket, there is nothing. Just one S3 bucket to host my Python code. Otherwise, nothing. I don't really need an S3. So all of my images that you see, they are being served through GitHub. That's another very interesting hack which I applied to use. So I use GitHub as my CDN for images. So again, paying zero money at all. So one for domain, one for Vimeo subscription, and that's it. And obviously for Zoom to conduct live classes, and one for GoodNotes. So the most essential things that are like non-optional to me is something that I got, but otherwise for hosting the LMS, it's entirely free and serverless.
You have any course creation feature and all you have created for this?
Yeah. Backend पे पूरा educator section is there. So in one click, I have one course creation का workflow, and I have a very small button called copy course, because like for the next code that would be there, I would be clicking that button and it would automatically copy my existing course into that. So agenda and all. Then the few things that needs to be changed is basically the course agenda, just a few lines here or there, depending on the cohort, and the live class link. The rest all things remains the same, right? So I just have that one button that does copy course. I have learner management, fees tracking, refunds, and emails, communication, email templates, all of that part. So soon you'll see all of those automations kicking in. Yeah, after the class is ended, just once I upload it, I post a message on Discord, you'll see that section like distributed ID generators being unlocked, and you'll be able to access it, and you'll get an email from Relog, or basically Team Relog or something. And then you'll be notified with that. So yeah, just trying to streamline things out there. It's a raw, crud. Basically nothing fancy there. So just tried my hacks, all of the hacks that I could possibly apply.
So the authentication is done via?
Great question. Authentication is done via Magic Link. Basically, the token I use is JWT token, which works for 30 days. Right, but then I would have to ensure that credentials are not shared and stuff. So only one session remains active at a time. So I've done IP level checks. So one token, so at any point of time, only one session can be active from an IP address. So if two devices log in, they would have different IP addresses, and the first one will automatically get logged out. So it's normal JWT based authentication. So I don't really have to, have a session based auth or anything, just normal Magic Link JWT based. So every time you do a login, it would send you a Magic Link onto your email, clicking on which will verify the Magic Link and would log you out from all other sessions.
Okay. So, but then subsequent request made to relog would have the same token, right?
Yes, would have the same token.
Okay.
So, but every time I'm checking for the IP address. So from which IP did I get the request? So that is the extra check which I'm making.
So in between, if my system's IP got changed, right?
Then you'll be logged out. Then you'll be logged
I'll
out.
be logged out.
Yeah.
Okay.
But it was very
But
hard.
generally,
For me
but generally system IPs do not change, right? Like suppose
Yes.
if you like, how many devices you connect, like, the IPs which are like pretty much static nowadays, like Geo Fiber or Airtel, whatever it is,
Yep.
your public facing IP. I think you should be getting the public IP, right, Arpit?
Yes.
Yeah.
The system, the IP of my system did not change in last 2.5 months.
Yeah,
It's
yeah, I
exact
get
same.
it. So I was trying to host I was just trying to host a web server on Raspberry Pi and doing the port forwarding on the Geo thing. So Geo thing, something I ran into some issues. I couldn't do it further. So I need to work on it again. It was one of my pet projects like long back.
No, for Geo, but basically they use CGNAT. So it changes, like, as in your public facing IP address can change anytime.
It can change anytime, but how frequently is it changing? Is it changing very frequently?
Check that, but from what I know that Geo has very dynamic routing policies. So
Geo might have. So if you're 100% on Geo, then your IP might change very frequently. So then just reach out to me. I'll make some arrangements for that.
no, I was just saying about basically how Geo laid out their network.
Yeah. So for a bunch of, like, mostly on pure mobile network, you might see IP address changing very frequently, but in most cases it doesn't. So if you are on a broadband or on a Wi or on your home internet, which is like a wired connection, then IP doesn't really change that frequently. And anyways, for the JWT token, I have enough, and like in once in 30 days, you might have to log in again if your IP doesn't change. So that's how I've taken an approach. So I tried implementing device-based stuff, but it was getting too complicated, too much of edge cases to handle. Let's first roll out with IP address, and then if this becomes a problem for anyone, I'll implement device-based. But I would not want to. I would not want to improve on something that is not a problem, right? So if this becomes a problem, like IP changing too frequently for a bunch of folks, I'll implement device-based stuff. Otherwise, it's okay.
So you also mentioned that you are spinning up Flask every time. Why that route?
Because it's hosted on AWS Lambda, na? It's not hosted on EC2 instance.
Okay, so but in that case, if a particular Lambda function takes more time, then it will be costly for you, right? Or
yeah, but it will be costly, but not as compared to like running a dedicated EC2 instance for a long time. So Lambda functions pay, you get 1 million invocations pre every month. What are the odds you guys would be making 1 million requests?
Yeah, so it's up to us if somebody really wants
to have my AWS bill short up. Yeah, go ahead.
Secret has been spilled.
load generator on yourself.
Run a load.
Everyone's writing the load generation script now.
Nice. Just some hacks around this stuff. But if I reach till that point, it's okay. Because in any case, even if my execution goes beyond 1 million requests, it's still cheap. Till 5 million also, it's okay for AWS Lambda. It would hardly cost me $2 for that. Plus taxes around $3. So that's still cheap. So basically that is why I kind of love serverless, because when you don't care about performance, serverless gives you great performance. But basically a great cost benefit over performance. Nice.
So Arpit, is it like we are triggering one Lambda for each request?
Exactly. One Lambda for each request, but AWS might choose to not spin up a new container to run the Lambda. So now that we are on the topic, how serverless functions work is typically for every request, a naive approach is to create or to start a new container to serve that request, right? But now what happens is, typically the time to to start a container is very high, right? As compared to the time it takes to serve the request. Let's say if you want to get a certain thing, it might just take 2 milliseconds for your database call to happen, right? But the startup time might be like 15 or 20 seconds. So for every request, you can't wait for 15, 20 seconds or something like that. So what AWS on that part, what they do is since startup times is something which is non-optional, and it's the fixed cost that you are paying. Startup time is always going to be like 15 seconds to boot, to basically start my Flask server. So a better way to handle this is when the request comes in, and if I've started my container, so I can keep my container running for, AWS does not choose to kill the container immediately as the request was served. It waits for some time. Let's say waits for 1 minute more, right? Expecting ki in next 1 minute, there if any request comes up, it would be forwarded to the same running container. Right. So it does not. So although from the outside it would look like every request is new container, but typically they are all served using the same sort of actual physical Docker container that they might be running. So if it's already pre-warmed, the subsequent requests are served faster, because it does not have to go through the entire process of spinning up a new container, because one container is already run. But after a certain time, if it does not see any request, it basically kills off the container.
There was one very interesting video on YouTube about this from some guy called Ben Award. He kind of checked all of the provider serverless, like how exactly do they scale? Like if you increase the RAM, does it increase the performance or not? As in the, I guess you can specify how much RAM and those things.
Dalona post karo na, बहुत interesting topic. Please post na, search and post na. This is very interesting. You know, the way serverless is moving, it's really fascinating to like understand the kind of optimizations they do to like just save cost. And once you amplify the cost to the scale at which they're operating, it saves them millions. So
yeah, no, also to say, like, to face this issue, right? The issue that we faced while booting up the very first request, right? So in our firm, what they did was they developed a small application and they named it Slow Burner. So it just sends a request every like 2 or 3 minutes.
Yes.
By the time it expires.
It's basically keeping it warm. So, but with that, what happens is there is always something running. So it's essentially like an EC2 instance. So the costing goes a little high.
Yeah, a little bit, but it's better than a low performing. Like it was based on the trade-offs.
Yeah, I totally agree. So I did have an option of basically keeping my servers warm, basically keeping my Lambda warm. But when I did, I accidentally deployed SQS consumer on Lambda. So SQS does not notify. It's basically not a push-based thing, but a pull-based thing. So my SQS consumer would continuously pull the data. So which means my Lambda, which runs SQS consumer, has to continuously keep on running. With this, what happens is I was getting billed quite a bit. I billed about $5 that month without even consuming any message, because that's how it used to function. So it used to ping every 5 seconds to see if any messages are available. So it basically essentially meant that my Lambda is continuously running. The RAM allocated to Lambda was 256 MB. So every time 256 MB ka machine was like continuously running for months. So that month I got billed for $5.
Arpit, I have just one more question. Our data, like we as a user, we mostly will be seeing the static data, like the video or maybe the content, the notes. So that we are hosting through GitHub, like you mentioned.
No, that is not hosted on GitHub. GitHub is CDN to host images, but bunch of images. Video is embedded using Vimeo. Notes will be uploaded to S3 most probably. Yeah, for that I'll need to create one S3 bucket. Yeah. So for GitHub page, it's only this thing. GitHub is only the public images which are there.
Okay. And for what purpose we are using this Lambda? Because all this content we can only view through the static data only. Means
although it's static, but authentication request.
Authenticate. Okay.
Authentication should go now, and then for all the session data and also whoever has the access. So if I give the authentication request, but then if someone is authenticated, I need to ensure that this code's data is accessible to only this code. That check is dynamic. I can't have a pure static website where entire content is also made static on that.
Okay. Yes.
Correct. So that has to go through API only.
Thanks, Arpit.
Chalo.
Arpit, why you didn't prefer an LMS, open source LMS like OpenEDX and Moodle and all are there,
I
right?
tried that. They looked really bad.
OpenEDX, I know in Python it is bad. Moodle,
Moodle
I
also
want
I
to.
checked. Moodle also I checked. But two reasons. Hosting one, hosting it on EC2 also required at least 2 GB machine because it required spinning up a database and all. And number two, it didn't have the customizations I need. Like especially for this cohort-based course, the kind of customizations I seek, like I can medal this thing however I want, like basically downloading a calendar file, giving you upcoming sessions, hosting extra sessions for such specific cohorts, like all of those part was like missing onto that. So मतलब बनाने में it hardly takes us a week or so, and just on night, every night I spend 1.5 hours on that, and it worked wonders.
Arpit, you just mentioned that for serverless, if subsequent request will be served for the same container, is the same IP or different IP?
Same IP has to be same IP for the container.
So if a different IP,
serverless,
it will spin up a new container.
What?
No, you just mentioned like for serverless, subsequent request, like if
yes,
if there's
it
no
goes to
one,
the same container, yeah.
So is it the same IP request coming from or the different IP? It can serve the same container.
Even from different IP. So at that, the server which is serving the request is the same container. Right.
Okay,
so
if
that
other
container's
person,
IP is not changing. No?
So if other person is writing query, it will spin up a new Lambda or it will be serving the older container
So
itself?
my one container can serve multiple requests at once. Na? So the concurrent request that it can serve is multiple.
Okay.
So I don't need to spin those many Lambda, those many containers. So AWS does not really need to spin those many containers. One container set can serve a bunch of requests. Chalo. Baki is pe, if you want to discuss, we'll discuss at the end. Chalo, let's jump into all about IDs. Like this is one of the most like it's like a fascinating thing. Like while I was reading about this stuff, this was like really interesting to me about how people solve ID generation. So ID generation is a very, very, very complicated problem. We will understand why it is, but it is extremely important to solve it. So ID is typically what? ID is typically any unique thing that you give to a database. So any unique representation, any unique identification to any entity is something which is the ID of that stuff. So you should be able to identify the entity using this identifier is what the ID of that object is. So now, given this thing, what are some IDs that you have seen in action at work, read about it? What are the different strategies to assign ID to an object? Madhav, what all have you seen?
GUID. GUID.
GUID, okay. Globally unique identification will come into what GUID is and how it does. Other ID generation thing?
Increment one, like normal.
Integer increment one. Incremental IDs, rather auto increment IDs of databases. What else? Or if you were to give ID to a certain thing, what would you use?
I've even seen timestamps being used, Unix timestamps.
Timestamps as ID, yeah, very plausible.
UUID.
UUID, brother of GUID, similar. Actually, both are same only. UUID, GUID. Actually, there are two versions of UUID, 4 and 6. So 4 matlab thoda chota, 6 matlab thoda little bigger ID, the way it's entered.
I think, and one of the UUIDs also uses the timestamp as a basis of ID generation.
Yep. Any other example? Thanks. Think, thoda sa think.
Hash.
Hash, yes. an MD5 hash or checksum CRCs or any sort of lossy way to convert your data into some sort of representation. So MD5 hash is a classic example of it being used as an ID. A lot of applications use, although hashes have a problem of hash collisions, but still a lot of products, a lot of real world products use hash as an ID because the chances of collisions are very less. Right? But that's what makes hashes very, very special. We will come into how using hashes you can leverage a lot of, you can build a lot of really robust systems out there. We will go through 4 or 5 of them in coming weeks. These are sufficient. Four great examples. GUID, auto increment ID by database. Timestamps can be used as an identifier. Hashes of data. Let's say you want to store a document. So that document ka hash could be the ID of the document, right? So, but if the document changes, then the ID changes. So that's, so you can't always have those things. I not store ID in the database, but like on the runtime, if I generate it. So there are multiple ways to handle IDs. But typically, the most common example that almost every one of us has used is using auto increment IDs of our databases, typically relational databases, that helps us give a unique identification to a row of your SQL or your relational database. So the problem statement that we're dealing with is, write a function that spits out a globally unique identifier every time it is invoked, right? This is the global statement that we are operating at, right? What is the unique thing with time, right? As time progresses, what is something that is unique for that instant? It is time itself. So in most cases, you would see that ID generation has something related to time, right? Because time is something that is never going back. Time always moves forward, and at every instant there will be a new value of time which we have never ever seen before. This is why in a lot of ID generation algorithms, time is one of the most critical factors, right? So a very, very basic function that you can write is every time get ID is invoked, it has to generate a new ID. And let's say what we do is get epoch milliseconds. So you can have it milliseconds, microseconds, nanoseconds, whatever granularity you would want to work for. And this is what our ID generation function would look like. So this is a great start because every time it is invoked, it would be invoked at a particular instant in time, which is kind of unique, and it would serve it. Where it actually breaks is, let's say my get ID function generates ID for like get epoch milliseconds. What if this function is invoked twice in the same millisecond? Right? You'd say, array, it's not possible. This is possible when at two cases. Number one, where you have multiple threads invoking the same function. So within the same millisecond, two threads might get scheduled because CPUs are faster. In the same millisecond, two threads might get scheduled, or even on the two cores. If your threads are running, not on just one core, if on two cores your threads are running, then there is a very high chance that both the threads execute at the very exact same millisecond. It may not be in the same microsecond or nanosecond, but definitely in the same millisecond, because millisecond is a quite big of a time. Given that this function would spit out the same value for both the threads, so then your ID is not used. Second example, instead of having threads, just imagine you have multiple machines on which the same function is getting executed, right? So there is a very high chance, because both has its own sets of CPUs. So it might actually generate the same ID for when invoked at the same time, which means your get ID function is still not globally unique, although it's a great start, but this is still not a globally unique thing. So we can obviously do better. So now, if you have two computers or two threads, and if you would want to avoid this problem, what you do is you append or prepend your computer ID or your server ID or your thread ID, anything. You can concatenate to it to make it unique. Because now with this, what would happen is you are prefixing your ID with your computer ID. Let's say this computer ID could be your thread ID, THREAD. It could be a thread ID, or it could be a server ID, or it could be your system ID, or it could be any sort of distinguished way because of which the collision is happening. So if your code is running on two different computers, you can use computers MAC address ka hash as something that you would concatenate with. right? So this is a great way to solve the collision problem, right? So concatenating computer ID and then your time that you have. So get epoch millis, where you get the time and you concatenate your computer ID with time. This ensures that you would never ever have that problem of collision, right? Now, what if we invoke the same function twice within the same microsecond or millisecond, right? So when it is being, so although this solves the problem of, when you have multiple computers, but if the same thing is done by the same CPU or by the same machine twice within the same millisecond, right? Instead of micro, let's take milli because that's a much bigger. In the same millisecond, what would happen? We would see a massive collision, right? We would not have a unique ID sort of thing. So to solve this problem, what typically we do, we have a static counter. So we concatenate the computer ID, the time, and a counter. And this counter is always auto incrementing, which means that even though we have collision, but if 2 times the same function is invoked, my counter's value, so this particular counter value would always alter. So would always do a plus plus. So now this counter is never going back because it is always doing a counter plus plus. Right. So this way, this would solve the problem. And since this is a static int, this would be allocated on heap, which means it is not local to this function, but a global variable. So this is another way to handle collision. So you have made things a little complicated. Now your ID is what? Your computer ID, your time, and your counter plus plus. Right. Now what would happen is, so here, here if you notice one thing, the 2 components out of the 3 for this ID, which is computer ID, time, and counter, my time and my counter both are typically monotonically increasing. So these both the entities are not coming back ever. So we can like get rid of time totally, right? Because time is not serving any purpose. Because if I can guarantee that every time my function gets invoked, I'm always doing a counter plus plus, my time is redundant, right? Because my counter is always being plus plus, multiple invocations, my counter would like do it well. Every time it's like 1, 2, 3, 4, and 5. Similar to time, it is not coming back. So time is something that would make, that is not really relevant here. So time becomes redundant, we can get rid of it. So we can just have a comp ID and a counter plus plus, right? Now this adds another problem. Where what problem it adds? Like, what if my machine reboots? Once the machine reboots, my counter would be reset to 0, right? So this counter is a static int, which means in RAM, it is being stored in heap. My machine rebooted, so my counter became 0. Once my machine restarts, the counter again starts from 0, which means my IDs are, which means I'll continue, because now ID will start again from 0, 1, 2, 3, 4, 5, 6, which is obviously a bad idea because I would have a ton of collisions. Solution to this problem is we would store the counters on the disk. Correct. To handle the reboots that we have, we would store the counters on the disk. That is a very classical solution. But what does this mean? This means that we would be always doing a disk write every time I'm updating the counter. So now my get ID function gets changed to get ID static int counter 0, doing a counter plus plus, but as my counter is doing plus plus, I'm storing it on the disk here. But this call is very expensive. Once I'm storing it on the disk just to handle that reboot, now my get ID function pay and every call, I'm doing a disk IO, which is expensive. So I should not be doing that. And then I'm again just doing a concatenate of comp ID and counter to like return it, right? Can we do a little better? Yeah. Question? Any suggestions?
Store in a centralized cache if we have one.
Then instead of local disk IO, it becomes a network IO. That's even slower.
We can store a counter, like say 100 more than what our existing number is, and we disk write only after 100. So we do a disk write once for 100.
Correct. So,
and and like we might end up
Also,
you wasting some, but it's fine.
Any other approach?
on boot up, we can like do some multiplication of the counter or something like that.
But how would you know?
So
But how would you know what was the last counter that you utilized?
so we may be doing like infrequently we can do a disk IO, like saving the
Correct.
counter.
That's what the solution is, right? So not doing a disk IO every time, because doing it every time was an overkill. So that's what we do. Instead of writing it every time, we do it once every 1,000 calls, right? Which means we have reduced our disk IO by a factor of 1,000, right? So now every 1,000 requests, and then once we boot up, we just add plus 1,000 because that's the edge case, right? Because like you basically you load the counter from the disk, do a plus 1,000 and start from that point, right? Which would ensure that you would never collide. Like from that machine, you would never collide. So static edge counter, upon every boot, it would load it from the disk, do a plus 1,000. So this 1,000 is nothing but whatever your basically whatever your frequency is. So once every 1,000 issue of ID tokens, store this ID locally or on the disk, right? And then you would have, and then you do the normal counter plus plus, and if counter mode 1,000 is equal to 0, then you do a save counter to the disk, and then your other function remains the same, where you concatenate your computer ID to the counter and return it. Right? This solves a very interesting problem by by basically deferring the IO call, or by just trying to delay my disk IO. Okay. But you would say, this all of this exists. The first option when I ask you any ID generation scheme that we used or that you used, people was like GUID or GUID, UUID. So if this exists, right? So what is GUID or UUID? So these are like globally unique identifiers. These are possibly the most famous way of generating random IDs. A great way to understand which website uses UUID, GUID is just keep a very close eye on the browser URLs. The kind of URLs you see in the browser, you would see the typical pattern, and you can identify, this is using MongoDB, this is using UUID, this is GUID. It's very evident from the browser URL itself. You can very easily deduce what kind of systems would they be using, right? So just keep an eye on the websites that you frequently visit, and just kind of observe what kind of ID generation are they using. Have a close eye on how YouTube does it. It seems random, but it is not. Keep an eye on the kind of alphabets do they use, what kind of problems are they solving by making that conscious decision, right? So ID generation is not an easy problem. It's a very interesting, a very tough problem to crack, but a lot of companies have tried to basically find a way out into solving it. Okay, so UUIDs are 128-bit integers. So the total width of a UUID is 128 bits. These are randomly assigned ones and zeros, and they are not sequential. So every time you assign or every time you create a new UUID, it would give you a random ID or a random string of 128-bit integers, and definitely not sequential, which means that the next ID, or if you generate two UUIDs, the second UUID might be so the value might be greater than the first one or might be lesser than the first one, but there is no guarantee onto it, right? So this sort of IDs hence does not fit well in the SQL schema of things, because where we have a habit of auto incremented IDs. You can't use IDs to do any sort of conflict resolution, or where you would want to secure it. If this is monotonically increasing, I can do something about that, because UUIDs does not guarantee monotonicity, right? So being not sequential, although it looks like a bane, but it is a boon. So it is great for security. Like we are all typically taught, if you are building any application, never expose your ID to your users. We are always told that. Why? Because if you are using SQL, if your design is based on SQL and you are using, obviously, like always, auto increment IDs, it is very easy to scrape your website, because they know that after match 17250, there would be match 17251, then 17252, then 17253. This makes things very predictable. If someone would want to bomb your website, person can very easily do it. So being not sequential is actually a boon for UUID. So if you want to have something like this, which makes it harder for people to guess your ID, like think about YouTube's video ID. Like how, basically, can you guess a YouTube video? Basically, what would be the next YouTube video ID given a video ID? Right, you can't, because it seems so random. Right, that's an advantage. That's an advantage to have with respect to security. Right, there might be few things that are given one after another, but it is definitely not monotonically increased. Right, but the biggest problem with UUIDs, although it sounds great, everything was fancy, they are too long. Like 128-bit integers, they are too big for any database to hold. Like you'd say, "Arey, it's 128 bits. What's the big problem?" Imagine storing a billion rows where each row has 128-bit integers. Just imagine the kind of data you would be just spending on storing IDs, right? So the problem never occurs when you have like 5 rows, 10 rows, 15 rows. The problem starts to occur when you are building systems at scale having millions and billions of rows. Like just expand it to that level and you'd start seeing the problem, right? But this solution is interesting for distributed space. Like ID being too large, you can have a lot of manipulations around it. With respect to the distribution, hashing is very simple. It gives you like near randomness, because IDs are random. It gives you near randomness in your distributed system. But again, the problem there is non-sequential. What advantage do you get if you have sequential IDs? Any guesses? Not really guesses, but any understanding of yours around what advantages would you have if you have strict sequential IDs?
Ordering, conflict resolution.
So range queries?
Pagination, fetching data using pagination.
Wait, I'll write. There are two really interesting points here. Wait, if you have monotonicity, the first point was ordering, as in pagination or something. But how come? What would you do here?
You can have offsets, right? Offset and limit, and you can fetch.
So doing limit and offset on IDs is what you're suggesting?
Yeah.
Okay. Ordering, so limit plus offset on IDs. This is a great way to paginate, but offset on IDs. Okay. Great way to paginate. Another was conflict resolution. If you'd want to expand on that.
If you want to know which event happened before the other, like a notion of what happened before the other, if you want to order, do a merge or something like that, and you want to know,
why would you need a use case like this?
supposing you have a strategy where the last right wins or something like that, you want to which should finally win over the other in case of right, yeah, it's basically to have a notion of time, like what happened first, things like that. If you want to know any use case where you want to order events in a system.
Yep, exactly. So monotonicity, although it sounds scary, why do you need monotonicity? But it plays a very, very, very major part into doing conflict resolution. Conflict resolution is something that happens always in any distributed system. Like two people doing the same transaction on the same object. Like, and if you'd want key, the last right wins, as basically very well put, that if you want to have key, the last right would always override everything else. If you'd want to have this kind of thing. So basically, if you'd want to find if the chicken came first or the egg came first, you would be assigning IDs to them. Whoever would have come first would have a smaller ID as compared to the later one. And this is how you would find who came first. Right. So if you are building a system that gives you guarantee monotonically increasing IDs, you would have very easily found which came first, chicken or the egg. Right. So younger and older, anywhere where you would want to do conflict resolution. Right. Any place where you would want to do something like this, because timestamp is not a good way to handle it, as we have already seen. Right. Because you can't rely, there might be conflict if, let's say, two transactions originating, basically the counter argument that you might say, is like, no, but we can use timestamp for this. Just imagine two transactions originating from different machines at the same instant of time. Then that is definitely not monotonically increasing and both will have the same timestamp value. Now, how will you do conflict resolution? Correct. That is why you need an authority that gives you monotonically increasing IDs. This would ensure that you would be able to find which transaction started first and which transaction came in last. Where will you find its actual genuine use case? A great example could be taking locks on the database. Right? Let's say two transactions running, and the first one, so basically we want to acquire who would get a lock. Right. So the transaction that came first will get a lock, while the other one transaction might get killed. Right. So these are actual genuine use cases where you would need monotonically increasing numbers like IDs for that purpose. Right, to do this. So these are two very classic cases where you need monotonically increasing IDs. So typically could help you resolution in IDs. Ordering limit and offset is a very interesting use case. I'd be expanding on that in some time because there is like basically 5-6 things that I want to cover, and then we'll expand into how you can do efficient pagination using IDs. Like you will be like mind blown ho jayega in case you don't know that. Like you can have a much faster performance if you paginate on IDs. Okay. So now what we do is now that we want monotonically increasing IDs, one very interesting thing that we can do in the first function that we have, like we have computer ID and time. Instead, just switch the roles. Like instead of prepending computer ID to the time, append computer ID to the time. Right. So now what would happen is, as time becomes the left part of your ID, it gives you increasing. It will always have it will always be increasing. Right. Why? Because MSB is something. So because now with time being on the left side, which means time is the MSB of it, and time always moves forward. So your IDs with time will always move forward. Although there are still problems, right? Along with having conflicts like this function getting invoked twice within the same code. But this is where what I would want to stress on is not to see this as a solution, but see the approach of keeping time on the left-hand side. So by putting things at the most significant half of your value, you are always gaining something. Like with time on the left-hand side, what you are gaining is that time is part of an MSB, time always moves forward. So here, the final ID would always be moving forward, right? Because the comp ID is something that is appended, right? Which is after it. So lower computer ID will come prior to then the computer ID, which has with a computer having basically having a larger computer ID or something, right? But you'd see that most of the ID generation algorithm has time on the left side of it, just to ensure that my time is always increasing, right? So this basically kind of ensures that for a certain time period or whatever the granularity at which you are operating for, you would always get monotonicity, right? We'll come to see why, and obviously this thing, there is another problem to this, that this does not actually guarantee monotonicity. Like this particular thing, like time keeping it first and then computer ID, just keeping time at first does not guarantee monotonicity. Like this was the first approach that we took, but this has a problem. Like this doesn't guarantee monotonicity because the clocks across machines are not in perfect sync. Up till now, we never discussed clocks. Up till now, we were just saying that time is there, time is Unix epoch and all. But while doing that Unix epoch, while finding what the current Unix epoch is, it uses machines clock, right? So the clocks are never in perfect sync, right? I'll come to it in. Let's do this. So let's do a little detailed understanding of why do we need time on the LHS of ID. Like LHS would be the most significant part, right? So once it is the most significant part, it makes sorting easy, right? You would always So once you have a conflict in the first half, basically, which is time, once you have conflict there, then your second half would just act as a tiebreaker, like who wins or who not, like in the same timestamp, like something like this. Let's say my time format is YYYYMMDD, like as a string, normal string, but you can convert it into epoch if needed. But obviously, this is also monotonically increasing time representation. So consider this. So for 2019-0101, my ID, or let's say my computer ID was 0001, right? So 2019-0101, then 0001, 2019-0102 pe 0001. After every day, my counter restart, my counter resets to 0, right? So now for the first day, I am having 0001 when my first transaction happened. On the second day, when my first transaction happened was this, my second transaction happened was this. Right, so 0001, 0002. So within that same, so when my time is on the left hand side, ordering becomes very simple. But if I would have reversed this part, right? Let's say my counter was at first and my time was at second. There is no way I can order things. Like there is no way I can find out which came first, which came second, because my MSB is frequently changing as compared to my LSB. Rather, it should be ulta. It should be like your MSB is the time, while your LSB is something that, you know, is something very specific to it, like my machine ID or my transaction number or my auto increment counter or something. So this makes like all the transactions happened on the same time granularity. Let's say we are playing on days granularity. So on the same day, if I want to go through the transactions that happen, it would be very easy for me to go through, like 0001, 0002, and these are strictly ordered then. Make sense? Now, got it why MSB, why putting time on MSB is a great idea? Yes, no? Raise of hands, thumbs up, something. If not, I can cover this again, because this is the foundational thing that you'd need a deeper understanding of before we move to the next part.
Yeah, this is great, Arpit.
Correct. So now MSB, time on this. Now another use case is like conflict resolution. A quick short example. So IDs are assigned to transactions. T1 and T2, both of them updates the value of E to 20, E to 30. Both the transactions came at the same time. Now which one wins? So transactions coming in exactly at the same time, we need to know which one was exactly starting at first and which came second. So we need an authority to do that. So that's why we assign IDs to transaction, and the one with the higher ID would win. So both are trying to set, one is trying to set E to 20 and second for E to 30, right? So with the IDs assigned to transactions and the IDs are strictly monotonically increasing, it would help us do conflict resolution that the later one would win. Okay. Now out of sync clock issue, the time on, let's say I have 4 servers, and the time on each server, we always assume that the time is always Unix timestamp or something, but the time is not in sync with the actual Unix server. So the time across your API servers might have some deviation from the exact time which is there right now. So there what happens is, let's say I have my computer ID 2, 4, 7, and 9. My time on first machine is 23, second is 24, third is 23, and fourth is 23. So my second server, which is CID 4, is running a little faster as compared to the other 3. Now what would happen is when my get ID would be called on C2, it would give me 232. Like, so this is the number that it would generate as my ID. On C7, it would generate 237. On C4, it would generate 244. On C9, it would generate 239, right? So now this ID, so this sort of request which I'm getting, right? These are not monotonically increasing. See, it first generated 232, then generated 237, then generated 244, then generated 239. So because these are my 4 ID generating servers, right? Now let's have this understanding. See, C1, C2, C3, C4, these are my 4 ID generating servers, and the ID generation logic is have timestamp and concatenate my computer ID to it. Like this was something that we established here, ID and my computer ID, right? If I have this, now what is happening is my get ID function, I have 4 ID generation servers. My get ID is being invoked on any one of them at random. let's say the first ID was first get ID was invoked on C2, then on C7, then on C4, then on C9. So the sequence, this so then the ID which is being given out to me is 232, 237, 244, 239. These is not monotonically increasing, and this is why our assumptions of we also need to consider that my clock could be out of sync while generating IDs, right? So while using time as a part of generating IDs. Clear? So time being out of sync in distributed system is a common problem. So don't, if you're using it in existing systems, just evaluate on things like you might have some unordered stuff. Okay. So this is where the clock being out of sync has an impact on your ID generation logic. Right? Now what we have actually done is, instead of focusing on ID generation, our problem now boiled down to our servers being out of sync. Basically the clocks on the servers being out of sync. So let's put our focus more on the ID. So now what do? This is for sure that if you have multiple brains behind the system, it is very hard to, generate ID. So your ID generation typically cannot, your ID generation logic cannot be split across multiple machines. So let's say what do we do is you have a central service. Like you have one central server whose job is to, generate IDs for you. Anyone who needs an ID would contact to this service and the service would spit out an ID, right? And now this one central server, it runs the same function that we generated. Now, since it is running on that, and since the code is just running on one machine, it becomes very easy, right? Because, for the single machine, we were able to solve this problem. Because in the single machine, you had ID, you can have, so you have time and you have computer ID that remains same, and you might have a counter. Or instead of using time, you can just use counter to, have this continuously increasing set of IDs being generated from the server. So this solves the problem very much. Anyone who requires ID can go through it and do it. The disadvantage of this is, number one, in order to generate an ID, you would have to make a network call, a little expensive. And secondly, you now have a single point of failure. So if your ID server goes down, none of the clients or none of the machines who need ID can get one, right? So now if you'd want to, solve single point of failure, what we saw yesterday, like add load balancer, right? So instead of having one server, one ID generation server, we have two ID generation servers. Now anyone who requires ID, now this client one, client two, there might be thousands of servers who need IDs or thousands of entities who need IDs. They can contact the load balancer, it can forward the request to one of the ID servers and they can generate ID, but there is still a problem. With this, what would happen is, now ID server 1 and ID server 2, these are ID generation servers whose job would be to ensure that they are always in sync, or they are gossiping among itself to ensure that the IDs are monotonically increasing. So we fall back to the same problem that we had before, right? So that same problem that we saw before, it again popped up, because now this two server has to gossip among it themselves to ensure ki, array, this is the time that we generated ID. Now what do we do from here? So acha, you have generated till this, I've generated till this. Let's gossip and adjust our counters to this point, right? Because not both the servers might get equal requests. One is far ahead, another one is basically lagging behind and all, right? So these servers would have to gossip and agree upon an ID. So this is again a more complicated problem. So just give me a minute, Anshuman, I'll take a question. So we made this entire process of generating IDs super complicated with having a lot of network calls. So the network call is not just from client to ID generation machines, but amongst the ID generation machine to do gossips, and it's too complicated. A good system is never complicated. So just what we saw was a guaranteed strict monotonic increasing IDs can only be generated with one issuing authority, right? There is no way to distribute this, because if you're distributing this, there will always be an edge case, which is unhandled, because distributed systems are prone to failures or lags or partitions and whatnot. So this is something which we have to keep our peace with, that our ID generation logic cannot be made distributed. We would always need to, keep this thing in mind. There should be one issuing authority. That is when you will have a strict monotonic increasing IDs. like the strict monotonic increasing IDs is something that is a very key here. But situations change when we add some relaxation. So this is about like when if we are asked to build a distributed ID generation, how would we think about it? Like, so let's say we are allowed to relax some constraints. What if IDs are not integers? Something like UUID, where IDs were not basically non-integers, so it can be represented as integers, but not strictly an integer. You can have strings and stuff, or alphanumeric and stuff. What if it is what if no failover is required, right? What if what happens if we do not have a strict monotonicity? Let's say we relax the constraint of monotonicity. Can we do something around that? Okay. So let me take a question and then we'll move to the next part of it, and we'll probably take a break as well. Yeah, Anshuman?
Yeah, so I want to know at what granularity do clocks go out of sync, like milliseconds or microseconds?
Clock sync. So it is so it typically happens once every 5 minutes, but this is configurable. So clock sync with the global NTP server or any configured central authority server once every few minutes. It does not happen in microseconds or milliseconds.
No, out of sync. When machines go out of sync,
it goes in seconds and minutes also.
Oh, okay. Okay.
So why does my clock why my clock goes out of sync is because CPU might be overclocked, or basically a lot of process happening on the CPU, or your clock ka jo crystal hai, which is actually doing the ticking, slowed down due to any external factor, because it's a hardware.
Okay.
Yeah, the clock you have, so the machine clock that you have, it runs on a separate battery. So that battery is nothing but basically counting, or your clock is nothing but the counter of how many times your wo cesium atom wala thing, or your atomic clock, the way it works, it basically checks how many vibrations it is having, and it is having those number of precise vibration, then it counts it as okay, 1 second got passed or 1 millisecond got passed, right? So that thing is actually a physical hardware device. Even a cold temperature has an impact on clock, or a hot temperature has an impact on clock.
Correct. So if the data center gets heated up, there can be.
Yes. So clocks go out of sync due to, basically there are hundreds of reasons because of which clock can go out of sync. CPU load, a temperature, like let's say if you're playing game on your machine for a very long time, you would see a clock being out of sync for a minute or two. And let's say you have turned off your internet, right? So try doing this, play a very heavy game on your machine, turn off your internet. There's a very high chance your clock going out of sync. This was a bug which was reported to Windows, and then Windows said, Gary, you're not connected to the internet, so you can't do much because I can't sync it automatically. So people were playing games and machine got heated. Due to heat, the vibration got increased, the counter got mismatched, and clock was actually faster as well. So basically something like that. So a lot of physical factors affect the clocks of the system.
Arpit, one more question here. Hello, Arpit, am I audible?
Yeah, go on.
Yeah. So, like you mentioned that we can keep like 2 ID servers behind a load balancer. I mean, through that we can achieve some kind of like.
We are just trying to protect single point of failure, because up till now we had this one ID server was a single point of failure. The only way to avoid single point of failure is to put it on behind load balancer or something. Like, so even
but still you mentioned that we can't really achieve that
monotonicity.
Yes, but like in distributed systems, I think we learned about Lampert clocks or vector clocks. Okay,
that's for clock synchronization, and that's a very expensive process. Which is something that you're
vector clocks is not clock synchronization, right? It's just about like ordering your events in a distributed system.
Yes.
Okay, so can we do something like that here to get the ID generation algorithm? So I mean, implementing the same algorithm.
I totally forgot about the implementation of vector clocks, but it is also some sort of logical counter that is auto increasing. And in that also there is one central authority which is issuing that.
There's no central authority. All the distributed systems, I mean,
but then they would be gossiping.
Yeah.
They would be gossiping.
They would be gossiping. Yes.
Right. So basically, this is what would come over here. Like, so they would gossip to do something.
Okay.
You can achieve that, but that would be slower. Huh?
Okay. I mean, right, I never played across with it, so I'm not sure.
So these are genuine problems. So obviously, we would, while building a product, we would not never think about a problem like this.
Okay.
Right. So what we are doing is, so what we need is, let's say I'm building Instagram or I'm building Twitter and I need an ID generation. But if I am doing it at scale, this is something that I would run into. Right? So doing a gossip is a solution, but doing a gossip every time might not be a solution. So you can still do gossip, but let's say similar to how we optimize for batch writes. So let's say writing once every 1,000 calls. Similar to that, you might do a gossip around once every 1,000 issue of both the servers. You are just initiating a gossip to just confirm, okay, this is the ID at which we would have to start spitting things out. But this is like too complicated for most companies out there.
Yeah, I get
Right.
it.
So, but obviously, it's a published thing, and obviously a lot of systems are actually built on top of that. So that is in practice, but not something that we as normal engineers would actually use in day-to-day life. But obviously, vector clock synchronization and Lambert clock is something which would give you strict monotonicity with gossips in place. But again, that's where we said that we added a lot of network calls to the system, like just to solve a small problem of ID generation. So we will come into like a very interesting ways how other companies have dealt with it. Has a very interesting hacks and very interesting design choices that they have made to solve ID generations in general. So we'll come to that. So yeah, Vishal.
So what strategy do you guys use? Incremental one or GUI ID one at Unacademy?
No, we okay. So what do we do is we generate randomly created strings as IDs. So because like in most cases, even in learn.relog.in, you would see that the course ID is a random 6-digit string. Right? Because the number of courses that we have on a platform, they are not going to be like one course every millisecond someone is going to publish. Right. So for that, we use a separate ID strategy. If we are based on SQL, auto increment ID works really well. Since it has atomicity and isolation, it works really, really well. So auto incremented IDs work well, but the IDs that we expose to the user is typically a randomly generated string of 6 to 8 characters. And the IDs we typically expose is the course ID, but not the user ID. So every user has a unique username, and a course ID is something that is like eight character long, just a randomly generated string.
Okay. And the system like Twitter and Instagram where people
Yeah,
are
we will come to
posting
that.
and
We will
tweeting.
actually saw how, we will actually go through the system design of how Twitter and Instagram actually did that thing. So Twitter, Instagram, Discord, and Flickr. We'll go through these 4 case studies.
Okay, fine.
चलो ठीक है. Any Vishal? अच्छा तुम्हारा हो गया. Any other question in general before we go on a break, and then we'll come into the part of this. The existing solutions and the 4 case studies that I talked about. We'll go into it like what, why, how, and when. So we'll go through. So now that we have seen it's very hard to have distributed ID generators which are strictly monotonically increasing without overcomplicating the system. We'll go through the existing solutions and how some of the companies have built products around it. Yeah, Sanjay?
One way without using gossip is, can you partition the space like odd even and then do round robin?
You did a spoiler, na? We'll come to it. We'll come to it. So for everyone to just think about it, that's a great hack, which spoiler ho hi gaya, so basically Flickr did it. That's a great hack. So what if we have just 2 ID generating servers, like ID server 1 and ID server 2, let's say one is generating all the odd ones, while second is generating all the even ones. So although these will not be monotonically increasing, but it would still serve a purpose to a very good extent, right? But Sanjit, here, if you are targeting monotonicity, odd even would not work. You would still have like some glitch here and there, but it would work very well under most cases.
Right. But is
right?
there
because some requests might continuously go to ID server 1. Like you might want to have like strict round robin between the two. One is here, then is here, then is here. If you're doing that, then you would always have monotonically increasing IDs. Right. So odd and even. I hope everyone else got this. ID server 1 generating all the odd pair of numbers. ID server 2 generating all the even IDs. So doing always counter plus equal to 2, not counter plus plus. So one starts from the ID server 1 starts from 1, ID server 2 starts from 2. So 1, 3, 5, 7, 9. 2, 4, 6, and 10. And now the load balancer would always do a strict round robin between the two. So first from odd, then even, then odd, then even, then odd, then even. So this way, we would have a strictly monotonically increasing ID sequence. It's still easy to say in theory, harder to implement, but this is a very fascinating thing which Flickr did with their ID generation. We will go through that. Okay, why did they do it and how did they do it? Okay, chalo, let's take a quick break till 5:28 minutes from now, and then we'll cover the 4 case studies that we have. So Twitter, Discord, Instagram, and Flickr. And obviously look at the existing solutions, like why and how. So we'll ask a lot of questions. Why did they do it, and basically what was the rationale behind this, and how a company switched their strategy from one ID generation to another just to make it more efficient. So we have a bunch to cover. Okay, so thanks guys. So a great solution to this problem. So now that we understood that distributed ID generation is a big problem to tackle, a great way to handle this thing is something that my sister team at Amazon used to do. So the team that used to sit next to me in the same hall, they used to do this approach. So they had this central authority. So now if you see, the problem with having a central authority is like this thing. It gets too overwhelming for the central authority that every time I need an ID, I have to go to the central authority and get the ID back. So instead of doing it in that case, what if I make one call and I get 1000 IDs back? Right? That is a great way, right? Because similar to how we saved our approach into making that like my disk writes optimization, like not writing every time, is very similar to that. In which what we are doing is every client, whenever it wants to get an ID, the server instead of sending one ID, it sends it 1000 IDs. So now once the client exhausts the 1000 IDs, then it will make another API call. So my ID servers are not getting overwhelmed by this. Like that is a basically that is another way of building systems like this. So client, so we hand out a batch of IDs and client makes a request only when they exhaust. This is a great way. Another, so to implement this, you can have elastic file systems and network attached disk, gain like to have that concurrent effects and all. So in case you don't know what EFS or elastic file systems or network attached disks are, just Google about that and see how you can leverage it in this system. Not so with existing solutions, UUID is very good. 128-bit integers. Again, as we discussed, it's too large, which means it does not index well. What does this mean? It means that it becomes very hard on the database when we are storing these big of a numbers in index, because in index we see that in case of primary, in case of the regular index, so non-clustered index that we have, the ID, so what it stores, the value mapped to the row ID. So this value being present in these 5 rows, it shows the row ID of those 5 things. So given that ID would reside in the index, if instead of 4 bytes of integers, or let's say even 8 bytes of integers, you are taking like 128 bits of integers. So 8 8s are 64. So instead of having 64, you are utilizing twice the space. Right. So this is not a great source. So this is why indexes take a hit. Why? Because now my index size would become huge. And one pro tip, if you want to gain a great performance out of your databases, keep your indexes to a bare minimum. If your indexes are small and if your database is able to fit it in memory, it would have a massive impact on the performance, as we discussed in the first week. Right. So always in the first and second week. So always ensure that your indexes are small, which means the elements that are stored in the indexes are small. In this case, since ID is something that is, will have to be stored in the index. So if IDs are big, you are consuming far too much of space for IDs, which means your indexes would not be able to load. So your database engine would not be able to load your entire index in memory, which means the database would take a performance hit because it would have to do a disk read and then another read to get the actual data. So not a good, so it does not index well, but it would work well in the case of distributed where you are just doing one get something, not indexing. But obviously you pick your battles, like what you want and what you don't. So one thing that you can read about is what are the chances of collisions of UUID. It's a very interesting read. Just understand that part. Maza aayega jaan ke. Some math involved, but you would have a very detailed understanding about UUIDs and the chances of collisions that might be, because UUID is just random generated string, right? So there has to be some sort of collisions that happen. Okay. Another famous approach is like how MongoDB does it. So MongoDB, what it does is MongoDB uses a 12 byte, which means 96 bits hexadecimal representation. Although it stores it in bit string, but the human readable format that it sees, that we see, is typically a hexadecimal system. So what it has is, like other approaches, it keeps epoch seconds to the leftmost part of it. Right? It is there on the left part. So you would see from now on, every single case study that we go through, you'd always see time to be the most significant bit. So 4 bytes of epoch second, then 3 bytes of machine ID. So if the epoch seconds collide? Obviously it would, because the granularity is of 1 second, which is too big. Then it would rely on machine ID. Then from machine ID, if even within that same machine, if you have multiple processes, then 2 bytes of process ID, and then one counter of 3 bytes. So this counter is auto incrementing every time. Right? This is a strategy which MongoDB employed, but now this has got changed. As per the latest documentation, this has got changed to epoch seconds, a random number, and a counter. So if you see, it has kept 4 bytes of epoch seconds. It has merged machine ID and process ID into one random number and a counter. A great reason to do this is so it's what is just right here, UUID. So UUID is typically what 128-bit random strings of zeros and one. It is randomly created. So if you were using MongoDB and if you have machine ID and process ID, you are wasting a lot of space. Let's say in most cases, you would have MongoDB being run on one single node with one process. So effectively, every ID which is generated has the same set of this 5 bytes which are there. Which means that if that one node takes in too much of load, the IDs might not really, they are still IDs, but you are not leveraging or you are not utilizing the space very well. So if we replace this logic with something very similar to UUID, you utilize the space to a much better way. Like your mid 5 bytes of space could be a random number, which means you can basically coalesce a lot of stuff within it, and you are not limited by anything. So your middle part, in case of first approach, was same for all the IDs generated on that particular MongoDB shard. On the other hand, with the other approach with epoch second random number and counter, you're having a much better utilization of all the space that you have. Right? That is a MongoDB shifted from approach 1 to approach 2. So they used it quite a lot for quite some years now, but in recent last 3 or 4 version upgrades, they altered this approach. Right. Now starts our first case study. It's for Flickr. So Flickr uses database. So this is what they call. So they used a database ticket server. So a ticket server implemented on top of a database. So now what this ticket server is, it's very similar to the kind of tickets we get when we go to movie theaters. Or a better example would be when you go to parks. Each ticket has a unique number like 0001, 0002. It resets every day, and you get this ticket number. So whoever gets a ticket, and you would know that this guy came first, and then this guy, and then this guy. Right? Because it is monotonically increasing. This is something that Flickr needed. What Flickr needed was Flickr's data stores were sharded. They were MySQL based with multi-master replication. Right? They wanted to avoiding key collision to guarantee uniqueness. Okay, was the key problem. So now with multi-master replication, what would be there? Because when you have multi-master replication, you can't rely on auto increment IDs, as we already discussed, because you have 2 split brains, and if you have auto increment IDs, then there would obviously be some collision. So which means when you're having a multi-master setup, you can't rely on auto increment IDs. So that's where you need to inject ID on your own and not rely on auto incremented IDs. So to do this, Flickr needed an ID generation, something which they called as database ticket servers, right? To do this. So the first approach that they thought of, why not GUID? But obviously GUID, why not? Because they index badly, because they are too large, right? So if you cannot keep, so this is exactly taken from the blog. So they say if you cannot keep your indexes in memory, you cannot make your database fast, right? And this is exact, and obviously it makes sense, because otherwise you would are doing one disk seek for index and then going to memory, and you are doing, and let's say you are doing aggregation on indexes, it again is very costly. So that would not work. So, and obviously with Flickr, they wanted sequentiality. So Flickr, for folks who don't know, you can share photos on that like Instagram. So they wanted sequentiality to understand like which photo came first, which photo came second, and you don't get sequentiality out of GUID, so they dropped it. Now what's next? So they wanted centralized auto increments. So instead of doing this at multiple databases, so like with the multi-master setup, instead of doing this at multiple databases, what if we do it at one? So have one database, that gives you, IDs. So the auto increment IDs that you have. So, database already gives us IDs. Why not just leverage that? So have a separate database that would act as your ticketing server. Usme you can use auto increment and use that to do the insert into your main database. So this is exactly what they have done. Right. So instead of having so their ID generation logic is totally reusing the ID generation that is already given to us by database. Right. So what they do is they call something like this: insert ... on duplicate key update ... So this is a MySQL specific statement, which is a non-ANSI extension, which means you might not find it in other databases because it is not an ANSI standard. So what it says is, if insert causes a duplicate in the unique index or on the primary key, an update of the old row occurs. Right. So which means if insert fails and it raises any unique key constraint error, call the update that I have. Right. And this is something which got replaced to like replace into command. It works like insert. We will go into exactly what happens there. But replace into is something that works like insert, except if the old row has some value, or sorry, if old row has the same value as the new row for the primary key and the unique index, the old row is deleted and the new row is inserted. So whenever the constraint fails with replace into, then the old row is deleted and the new row is inserted. So whenever the unique constraint fails, right? We'll take the actual examples of what the database structure is. So this is the database structure. So create table ticket 64. So they are issuing 64 basically they're issuing 64 bits long integers as IDs. There's just one the first column is ID, which is a 20 which is a big integer, unsigned, not null, and auto increment. They will be using this as their ID. So this is a separate service that would give out IDs. Right? Now what would it have? Another column which is stub. Think of it like service, like which service wants this ID. Right. So this stub has character 1, not null, default is empty string, then a primary key on ID and a unique key on stub. So stub is just 1 character long. They would use stub to fail the unique key constraint, because this insert on duplicate key update and replace into, both of them requires that their unique constraint should fail, then only other statement would trigger. Right. So insert on duplicate key update and replace into. So both of this would fail only when your unique constraint is failing. So to explicitly fail the unique constraint, you need something, because ID is something that you are relying on. And so unique key constraint will always be failed on stub. And once the insert is done, you can invoke what was the ID which was last inserted. So you can get it using the command called last_insert_ID. It would give you the ID of the last row inserted or updated. So you'll get this information there. So this is how it looks. So you'd call replace into tickets for stub. So you'll update the value of stub and you'll put the value A. So A pay A would fail because A already exists. And now you're trying to insert A. So replace into is what they've used. So replace into tickets value A. So A already exists and you're trying to insert A, which means it would fail your unique key constraint. So for each use case, you would have one stub. So let's say A is one service, B is another service, C is another service. You would have those many stubs. And for each of them, you are having this one ID. Now, what would you do? You would do a select last insert ID. So once you do a select last insert ID, the ID from 8 would change to 9. From 9, it would change to 10. From 10, it would change to 11. And then you would use this to basically fetch your ID. Now insert into, so this same statement we implemented using replace into. Another way to implement it is using insert, we implemented using replace into. Another statement is we can use it is insert on update or duplicate key update. So insert into ticket stub values A, So we are again trying to reinsert A into my row, but A already exists. So unique key constraint would fail. So on duplicate key update, which means, yes, I have a duplicate key on A, which failed. What I want to do, ID equal to ID plus 1. So something like this. So once in this row, when I have A and I'm again adding A to it, my unique key index failed. So what would kick in? My duplicate key update. So this would kick in. It would do ID equal to ID plus 1. So what would happen is 8 would become 9. So whenever there is a duplicate key, do this. What are we doing? We are doing ID equal to ID plus 1. And then we would call select ID from tickets where stub equal to A. So this would run in one transaction. Correct. So since database already gives us monotonically increasing IDs, Flickr thought of using it and using insert into or replace statements to achieve this pattern. It was a really smart thing to do, right? So with respect to performance, duplicate key update. So the second approach that we saw, duplicate key update, is 32 times faster than replace into, because what replace into does is, so replace into actually deletes the old row and inserts another, while duplicate key update only updates in case of unique key constraint failed. So this was an upgrade done by MySQL. So they changed their logic from replace into to insert on duplicate key update. So this was this was the benchmark done by some blogger, and they wrote this is this much faster. So I ran a very small load test to actually see the performance difference, and I actually found somewhere around 27, 28 times difference. So obviously it should be floating around 32. So on local machine, I got that performance there. So insert key, duplicate key update and replace into. So this is like a hack. So instead of building your own ID generation service, if there is an existing component that gives you that, leverage that part. Leverage it to build your own system. So apply hacks to build your stuff. And obviously this is a great piece of engineering where they utilized everything that was already there. They just went through the SQL documentation and found out some relevant statement that they could leverage, and they leveraged this part. The problem with this was having one database server, because now it is getting a lot of requests, which means that it is a single point of failure. So now when we add multiple servers, we would again have that same problem, like saying and what if and what not. All of the problems that we discussed, how would we answer this, similar to like master stuff. Like, so how do we solve it? So what they thought was, what if ID space is isolated? So you would not have a sync problem if your ID space is isolated. So what did they do is they configured system like this. So they had two ticket servers, one that has an auto, so both has an auto increment of 2, but one starts with 1 and the other starts with 2, something that we already discussed. So one ticket server would generate 1, 3, 5, 7, 9, while the other one generates 2, 4, 6, 8, 10, and load balance using RR. So this is exactly the approach which Flickr used to solve their ID generation problem. So due to any reason, if my server drifts, so due to any reason my load balance are like, let's say one of my server went down for some time, right? But then it got back up again. So they just add buffer, like let's say 100,000 to both the values, like, and then they start from that point once again. So they would have this monotonically increasing IDs from basically generated on top of like their SQL servers, which always comes out of the box. Right? This is an interesting approach which actually Flickr is still using in production, and it has served them very well. Any thoughts, questions around this? How many of you were aware of these statements? Replace into and insert on duplicate key update. Have you used it ever?
Never.
Never, no. That's why, right? So we see almost all the tools that we use now have some or the other way to have our problem solved, right? But it's just that we never use it. We just have to be like aware about this, because while I was going through this was like pretty smart, and it was all along, but it is there in the database that they were using. So in most cases, whenever you are stuck with a very similar problem, just keep a very close eye on the things that you're already using. You might just find your way out in that problem. And
So
a
for
very
so for Flickr, they use this system for every photograph
yeah,
for ID.
yes, for every single photo.
So won't we run out of numbers at one point of time?
If that happens, that happens. So it's 61 bits, a big int. That's a very big number. So what would you do if you would reach that scale? And you have reached that point that, you know, all 2 raised to 64 numbers are exhausted. Now what would you do? 2 raised to 64 is how much?
Twitter has something I read about it. They have two IDs. One is short and one is double the size.
Yeah. So 2 raised to 64 is 1.8 into 10 raised to power 19. You know, you can't reach that.
Yeah, that okay.
Too big of a number, right? 10 raised to power 19. Matlab, baap re, such a big number. 1.844 into 10 raised to power 19. That's massive.
But Twitter, if Twitter follows the same thing,
yeah,
it has the potential of reaching that number, right?
We will come to that Twitter. What they do. So they are already using 64-bit integers only, but they have a different game. So they applied another very interesting approach there. Okay, we'll first just basically close out on Flickr for something.
So here the stub is per application, right? Or per process, right?
Yeah, stub is per application. So let's say you have one profile service, it would have its own stub. If you have another service for photos, you might have another stub for that. So so they kept it stub to be one character. So typically, instead of if your service is if your service has a very high throughput, you might want to have a separate ticketing server for that service, because the only job of this database is to issue IDs. That's all it has to do. It has nothing else of a job to do.
Yeah, but even in that case, for millions or billions of photos, right? Handling that in memory, right? As you said,
you would need higher capacity, but if you're having that throughput, you would always think of basically having a separate server for that, because that would be the most critical service of yours. Right. So basically that is exactly why they have stub of like care 1. So this is the exact thing which is taken from the block. So this is exactly how their tickets table look like. So stub care 1. So they did not mention a thing about piggybacking multiple services on the same ticketing server. But if we were to think about it, then at max it could go to like 26 many, up to 128 services on one box around this 128 or 256 servers services here. But if they are small, your database can handle that much of load, you can do that. But it is always better to have a high throughput service being given its own ticketing server to deal. So, any other question? No? Next. Next part is Twitter. I love how Twitter does it. Twitter has a very interesting has built something called as Snowflake. And if you see Twitter IDs, if you have used Twitter API, Twitter IDs are still integers to date. To date, they are actually giving you integer IDs. So you can change the ID and make a call to the URL. You might see actually a tweet there, the tweet which was sent just after this. So what they do is they do something really very awesome, right? Flickr had their ID generation at a single place. What Twitter says was, no, I don't want ID generation to be my central authority. What I would do is I would empower my API servers to generate ID their own, so to generate ID on their own and not rely on a central authority. But I would still give you roughly monotonically increasing, roughly incremental IDs. Right. So they don't want to apply strictness to it, but a rough monotonic increasing IDs would be good. So they use Snowflake. The Snowflake is also adopted by Discord and Instagram with slight modification. We'll come to it. So what Snowflake does is, I already saw someone sharing Snowflake. It's good that you know about it, but this might be redundant, but it's fun. So Snowflake, what it does is it has like 41 bits, first 41 bits, like all other algorithms to be timestamped. It is epoch timestamp in milliseconds. So epoch, we typically think from 1st January 1970. What Twitter says is, or what Snowflake says is, you can have your custom epoch. You can start from wherever or from whichever time you want, because like, why do you want to waste space? If your company started in, let's say 2001, why would you want to count your thing from 1970 epoch, right? You're just wasting that much of space. So let's leverage it better. So let's have a custom epoch. So it gives you that. This is a very interesting, it's a very interesting use of, or a very efficient use of the resources that you have. So having a custom epoch would give you far better or far bigger space than you would do if you are using epoch. Then it gives 10 bits to machine ID. This is not data generation. This is like normal API servers that you have. So the ID generation logic, up till now with Flickr, what we saw was ID generation logic was offloaded to a central authority. What Twitter did was, Twitter said that all of my API servers will have an ID generation logic of their own. So if I'm posting a tweet, my tweet request goes to an API server. That API server wants to store the tweet onto the database. So the database may, when they're storing the tweet, it would also store the ID of the tweet. So ID will not be auto-generated by the database. So now API server, when it is storing the tweet, the API server will assign an ID to the tweet and store this object in the database as is. Now, given this situation where the ID generation is the responsibility of the API server, the API server has to guarantee that IDs are unique. Now, what Twitter does is, Twitter built this Snowflake in which 10 bits are given to machine IDs. These are like normal server IDs, and then 12 bits to per machine sequence number. So per machine. So with 10 bits of machine IDs, which means a Twitter infrastructure using a Snowflake, this implementation of Snowflake can have at max 1024 API servers running, which is using the same set of, and all of them serving the same request, which is typically very high. Like you might not have 1000 servers serving just API request of yours, because you can always vertically scale, right? So you would always try to keep your infrastructure to that optimal size where it's not growing too big in terms of horizontal and also not too big in terms of vertical. So you can always vertically scale things. So 41 bits of timestamp, 10 bits of machine IDs, and 12 bits of per machine sequence number. So what a disadvantage of this is, there are languages like JavaScript does not support 64-bit integers. So that is why in the Twitter API, you would get a response, you would get two IDs, ID and ID underscore str. So ID is the integer ID. If your browser supports 64-bit integers, well and good, or if your client supports 64-bit integers. But if some of your language or some of your browsers or some of your clients does not support 64-bit integers, then it can use ID underscore string to user's ID. Right. So this was a very interesting. So that is why in Twitter API response you'll get two IDs. But those IDs are both exactly the same. If they are different, this means that the client that you are using does not support 64-bit integers. That's fine. But what does this gives us is snowflakes are sortable by time. Like first 41 bits is of epoch millis. So within 1 millisecond, right? So within one. So since the first 41 bits are milliseconds, so in 1 millisecond, your 1024 machines can parallelly execute your query or can generate ID. But there is this 12 bits of per machine sequence number, which gives it the uniqueness that it needs. Like it basically handles collisions very well. And once this is done, auto rotation starts from zero again, right? Once it is exhausted, starts from zero again. And this serves very well. So it is sortable by time. Now, a great thing is it gives us ability to get objects before and after a certain ID or time. Right? Since the first 41 bits is time, we can query the things that give me tweets happened after 10 p.m. yesterday. I can just compute the first 41 bits and I can just do it here only. Right? So it gives me the ability to make those queries very efficiently. And paginate on ID. Pagination on ID is very efficient. So if you have used Twitter API mein, while pagination, it gives you, give me the last tweet ID. So there is a field called since at. So you can specify key since, oh sorry, since ID. So since this Twitter ID, give me everything that has happened. So it is basically doing pagination on tweet ID. So you have consumed till this tweet ID, give me the next step. You have consumed till this tweet ID, give me the next step. So this saves us from making a bulk on limit and offset. So limit and offset is the worst way to paginate. It works well up till 10,000 rows, but after that it falters very badly. So that is something that is solved using this, using Snowflake-ish thing. In MongoDB also, if you see, if you can do it with Snowflake, this has first 41 bits of timestamp, then machine ID, then per sequence ID. This is oddly very similar to, MongoDB. You have 4 bytes of epoch seconds, then 5 bytes of random numbers, and then counter. So this is oddly very similar to MongoDB. So can we not sort things on ID in MongoDB? We definitely can, and it is a much better approach to sort it on that and not use limit and offset. Oh, sorry, and not use limit and offset. So what I did about sometime back in like 2017 something, I was trying to iterate through a gigantic MongoDB collection having 1 million documents. And like always, I use skip and offset, basically limit and offset there. And it went haywire after a certain time. And I was like really wondering how to do that. And then I found an approach which talked about, it was one very short Stack Overflow. Okay, you can query on ID. So that is where I did that benchmarking, and I've already written a blog on that, MongoDB benchmark or pagination MongoDB. You will find it on my blog, in which I compared the two approaches, one using limit and offset, another one using ID. So how we can leverage ID to do pagination very efficiently. That is something that you should definitely check out. So wherever you get a chance, and obviously if you're using DynamoDB, you would see that DynamoDB for its pagination always asks us for exclusive start key. It never gives you limit and offset. It always asks you for exclusive start key. This is exactly why, right? Because it gives you that flexibility. You have read till this point and it is sorted by that. So it is read till this point, give me 10 after that. So it gives you equivalent performance at every stage. So with limit and offset, what happens is, as your page, as you go to depth, let's say after 10,000 pages, it has to build up that cursor, query that, keep that in result set and go for that. And, at least go through those rows and then give you and basically fetch you that result set that you already see. So that is very expensive for your database to happen. So the better approach for that is, if you use this part, pagination on this, it would give you equal performance on every page, even on the millionth document. So let me quickly, share my screen and walk you guys through that, so that you can see the, because this is what matters. After a certain stage, when you talk about optimizations, this is all what actually pops up that you should be working on. No, you have to talk about benchmark. See, I've just done a very short benchmarking. See, you can see the results. So the green, so the blue one is how we, on what happens when you do limit and offset. So as my page, or as I go more in depth, like from one page to, let's say I'm accessing 1000th page using limit and offset, my response time continuously shoots up. So mean and count when page size is 10. So page size is 10, page size is 10 for 40, using skip limit and ID limit. So I did it for page size 10, 40 and 100. I saw this pattern, but when I was doing pagination on ID, I got a constant time response. No matter how deep was I going, it gave me that constant response time on that. And basically this is very evident. You should, if possible, you should always leverage pagination on IDs. This might not work where you have like custom where clauses and all, but if you're iterating through all the tweets or all the documents of a collection or something like that, go for an approach like this. This is another reason why Elasticsearch gives you a separate scroll API and not support limit and offset after 10,000 offset or something. It does not support. It says that please use scroll API after this. It gives you an exception. Right. So here we saw like how limit and offset like is not good after a certain stage. It would work well for some cases, but then obviously using ID limit approach, doing pagination on ID would always give you a better thing. Okay, so always keep in mind, just run your benchmarking numbers to get a deeper understanding. We can do something like this. Just always experiment with things that you have on your plate. Okay, so this is what makes Snowflake very interesting, because it has helped Twitter a lot to scale. The main reason, and obviously this is this is what I mentioned here. So I've written that Instagram and Discord also uses Snowflake. So what Discord does is, since Discord was formed in the year 2015, so what Discord did was Discord uses Snowflake with epoch equal to 2015's first second. So they use that as their epoch time. And Instagram uses Snowflake ID with 41 bits of timestamp, 13 bits of shard ID, and 10 bits of sequence number. So they use this sort of distribution to generate their IDs and stuff. Sony uses Snowflake and they've named it Sonyflake. That was a very clever play. So they use Snowflake and they named it Sonyflake. So you can find it on their GitHub. And it's a Go-based implementation. So if you know Go, if you even don't know Go, it's a very trivial, just one file implementation. Go through it. It will be a very fun understanding for you. Now, a very critical point. This is exactly why Twitter was able to scale. So Twitter scaled because ID generation logic was independent on each application server. So now there was no central authority to give it an ID. And the pagination was very efficient. And this is why Twitter can support streaming APIs, right? Because with streaming APIs, and let's say if you would want to move through some sort of cursors and skip something and go to a certain point, like I know that so with streaming APIs, what happens is you would always say that I have read till this point, give me everything after this. Correct. And this is how your streaming APIs typically work. See, I have data till this timestamp, give me all the data that happened after this. So if you were doing limit and offset, this would have been a terrible implementation. But with ID being sortable, with first 41 bits of epoch millis level tak, the pagination happening on IDs, this became very efficient for Twitter to handle. Very, very efficient. So the ID generation logic not being there with one central authority being distributed across made all the difference. And the scaling was like on application server, you did not have to worry about any central authority to scale and manage and have single point of failure and whatnot. Right. Obviously, it does not give you strict monotonicity, but it gives you a fairly good monotonicity that you always see. Now, Instagram was doing something. Instagram, like always, like let's stick to question. Yeah, Varun?
I mean, you said that you will. I mean, you can do. I mean, after. But let's say the ID. Let's say I have time and random ID and I mean machine ID and sequence number. I have the last. Thing, but when I request, but I mean in the same second there can be some other messages which are not sorted. So the extract and do the I mean in the same second there is a probability that I might lose something. So so how do they remove it? I mean they go to the previous second or millisecond and
no, with the same second. You said that they would lose out. So I was thinking around pagination, they might lose out on data. What were your point?
I mean, let's say I said, okay, give me all the records after this ID, this record ID, this record ID. But in the same second, there might be records that are not in the same order. The IDs are not ordered because the randomness.
Okay, so you might say, so you want to say that another tweet might be placed before it, which was actually generated after that time.
Yes.
So but obviously this algorithm does not give you guaranteed monotonicity. That's what it has dropped. It does not give you strict monotonicity. It gives you like eventual monotonicity or basically loose monotonicity. Along that time, like obviously clocks are out of sync on API server. That is still a problem. So one of the clock might be running behind and stuff. So it might generate an old ID. But obviously there are no collisions as such, but you will not get strict monotonicity. Obviously, I've never talked about monotonicity in the entire approach. It was there ki rough sortability on time. You cannot use Snowflake ID to do conflict resolution, to be really honest. But unless if it is on just one server, then you can do it. If you have distributed servers, you can't use it. Okay. Any other question? Chalo. Okay. Instagram, like always, was very innovative in their approach. Instagram, what they did was the IDs. Their requirement was ID should be sortable, 64 bits to be efficient on index and cache, and a fewer moving parts, because they were like 3 engineers, 1 year, 13 million users and all. So they were like they wanted very few people. They need very few moving parts. So what did they do? They took Epoch to be 1st Jan 2011, because that's when company was founded. 13 bits for shard ID, 10 bits for sequence number. Instead of using an external ID service, this is next level, right? What did they do? They used stored procedures to generate ID. So they created table like this ID. So they created a table. So this is a normal photos table. This is not any specific table for storing IDs. This is a normal, usual, simple table to store photos, like anything that you have, like to store photos and all. Photo URL, photo image URL, resolutions and whatnot. Those normal things. That same table, but the ID column, they have specified while creating the table, they specify it needs to be begin, not null, and whose default value is a procedure call. Insta5, which is nothing but a shard ID. So they have logical shards. So they have logical shards and physical shards. So Insta5 is, think of it like a separate database, but a sharded database. Which logically resides, which logically is separated out, but physically might be present on the same database. This is something which is Postgres specific. Because you can go through Postgres sharding to get a deeper understanding, but the approach is a brilliant one. So Insta5.table, and Insta5 is the shard ID or the shard name. Insta5.table and ID begin, not null, default, and a procedure call. Insta5.nextID. So now what does this next ID do? So every time I'm there to store the photo, and if I'm not given it an ID, if I'm not given it the ID, my database engine would generate the ID with default value. And what the default value is, it is this invocation, which is insta5.next_ID, which means it would invoke a stored procedure called next_ID, and which is defined as this. Okay. What does it define as? It says that create or replace function called insta5.nextID, which spits out result, which is of type begin. The idea is the exact Snowflake ID. So they implemented Snowflake not on the application level, but on the database level, right? And what they have done it is on the normal photos table they have did this. So they have implemented Snowflake like this. So they have a begin, epoch, begin 131422. This is the 1st January 2011 wala epoch milliseconds. Then a sequence ID, then a now millisecond. So basic variable declaration, and a shard ID. So 5 is nothing but your shard ID. Insta5, this is the shard ID. And at max they have support for 13 shard ID. So they have 13, so 2 raised to 13 logical shards of their Postgres database. Like, so that's what they are working with. So with this, their function is very simple. This is like normal C code that we see, like, but just implemented in SQL functions. So now MS is something to get your current time using the stored function that you have to get current time. You do result equal to now MS minus epoch, which means from epoch time that you have, now MS minus epoch moving by 23 places, which means the first 41 bits of it. Then you add shard ID. So result equal to result or shard ID left shifted by 10 bits. And then you result equal to result or shard ID or sequence ID. So this would do nothing but, so this sequence ID is something, acha, now comes the sequence ID wala part. Now, what's the sequence ID? Sequence ID is something that is auto incremented every time. So they get sequence ID using Postgres ka sequences that you have. So table underscore ID underscore sequence would give you the sequence ID. So every time the next well, so these are the sequence counters that are part of your database. So these sequence counters, it calls the next well to give you the next sequence ID that you have, and it uses this sequence ID to be added as the last 10 bits of your final ID, and this is what your result is. So they took the idea of Snowflake and implemented it on the database, but not as a ticketing server, but as their core database table, like your photos table or your users table. And this is how they generated IDs for their photos. Like this is a pretty neat trick, if you think. Any questions around this? Around how Instagram did it? And basically this is what all I wanted to cover about like ID generation. A few very interesting approaches around how Instagram, Flickr, Twitter, Discord, all of these guys did. But any questions around this approach or comparison in general? No? Is it Sunday afternoon that has taken an effect? Right? I hope you guys understood this part. If not, do go through blogs. I'll add the resources. There is already recording available. But obviously things becomes really interesting when they are done by like really smart integers. So this is a great approach that was done by Instagram, where they took the idea of Snowflake, implemented it on the database. So we saw that same idea of Snowflake being implemented in 3 different ways. We saw another approach by Flickr, which uses a central ticketing server to generate ticket IDs. Instagram idea was like next level, where they use stored procedures to, optimize that part. So yeah, basically that is it with respect to distributed IDs in general. Any questions around ID generation?
No.
या तो सब समझा है तो कुछ भी नहीं समझा. It's either of the two extremes.
Yeah, I think the Instagram one needs to be revisited. It seems interesting. But is it limited to Postgres or like any other database?
No, you can implement it on any database you want, any database, because every database supports this. Every database supports having a default to be passed in as a stored procedure. All the database supports it. It's an ANSI standard. What's specific to Postgres is how they have used sharding. Right, so this particular part. So this you can think like if you are using MySQL, this is like a normal MySQL database. So if you have like 6 databases in MySQL, say DB1, DB2, DB3, DB4, DB5, 6 databases within one MySQL server, you can call function like DB, you can access table like DB1 dot something, right? This is exactly that. So this is like logical sharding on Postgres database, and which can be split into multiple physical shards. So you can have 3 different Postgres servers. You can say, okay, this shard resides on this database, this shard resides on this physical server. So these are just logical shard ID, so that they are ready to scale whenever they would need to. So they just prepared. So they were just basically prepared very well. If they would want to split it. Now let's say they have thousands of logical partitions. They have thousands of logical shards, but physical one could be just 2 servers. And if they would want to add the 3rd server, they can just move a bunch of shard into other database by taking a SQL dump, downloading a SQL dump, and uploading it on other part. And so they were just very interestingly, they were just like basically future ready. So that is why they have implemented it this way. So for a certain shard, dot next ID is where the function is defined. So for every database, you have to, since it's a separate namespace altogether, so you would have to redefine this function again and again for all the databases that you have. So you can do it in MySQL, you can do it in Postgres. Just create your own database and write this function. The only thing that would change here is this. Baki, everything would remain the same.
But if they change the underlying DB, that is Postgres, to something else, or they move to NoSQL database sort of a thing,
then a lot of things would change, because but they don't have any plans to move to NoSQL. Right? So this has worked really well, because if you can get sharding out of your SQL database, then what's better than that? But yeah, in that case, still they are very ready with this, but their ID generation might change. So they might adopt something like Flickr's approach or even Twitter's approach to do that. But
why
this is
would
just like
go with
jargon.
DB? Why would one go with DB approach or an application generating an ID approach? I mean,
So
trade-off
that you are
between
not
both.
coupled to the database.
That
Right?
way, yeah.
Right. Yeah, correct. Otherwise, if you go for, correct, as basically very well put by Vishal. So yeah, that's exactly that would happen. Like if you are very coupled, so the Instagram's approach is although the most interesting one, but it is very coupled to like the database that you have. But if it is part of your application logic, like what Twitter did, where they put the logic in their API servers, like how they would generate ID, which means like no matter which database would you use. So tomorrow you might choose to move to NoSQL or SQL or Graph database or any random database. Your approach would remain fairly constant. Right? That's a great part to have. So yeah, I agree with Vishal. So these two approaches, so database ticket server and Twitter's approach, they are far generic and basically, to be honest, agnostic of the system, because one is like separate entity, you'd need to have database for that, but it does not bind you to use that database for your photo storage. You can use a separate database if you need.
But then there will be specific big teams working on specific this problem, right? Because ID generation for like for Amazon, tracking order ID and then different IDs, right?
Yep.
So for different ID generation, there's a different team or same team?
No, ID generation has a different team. That team used to sit next to us. So they gave us a talk on how did they do ID generation at scale. So that's why I got to know that's how they do it. So they use this approach. They basically batch 10K IDs this one at the end that period. What if you hand out a batch of IDs? So this is what they do. For every server that needs ID, so a database does not generate ID. IDs are part of application server. So each application server would ping this service to get 10,000 IDs. And once it exhausts 10,000 IDs, it would again ping to get the next 10,000 IDs.
Okay. So ultimately, will they be using these IDs and storing them in cache? Because again, it will be a very big thing.
Yes. So this 10,000 IDs, once application server gets the 10,000 IDs, it basically keeps it ready in the memory.
Not this. Let's say in case of Instagram, right? A particular photo will be having some ID. A tweet would be having some ID, right? So if a celebrity like Amitabh or anybody, right? So will they be storing these tweets against these IDs? Then it will be super big, right? The cache itself will be very big, right? Or if I say I want all the
not
tweets.
all ID needs to be stored in memory. No, only the batch ID that were returned to them would be stored.
No,
like let's say a batch of 10K.
Okay. So if I want tweets from a particular user, right? So in that case, that tweet would be saved against that ID, right? So in the cache, right? So that they can send.
So why would you store tweets in the cache? It would be there in the main database, no? Why cache?
So but if they are doing a query against main database, then it will be a slow, right?
So that would anyway happen, no? Because for that you'd have to go to the database to get the paginated results. Would you store all the tweets in cache? No, right?
At least some. Latest ones.
But that would be like one page for all the verified profiles. That's it. And that too only IDs of it. Maybe that as an optimization. But mostly that doesn't how that is not how Twitter would cache it, because like that would be too big because there are far too many verified profiles. So
okay, sorry, if I keep on scrolling Twitter page, right, super fast. So you're saying that it will be constantly hitting database servers.
Database servers, yeah.
Okay.
It would constantly hit the database server because you would have an index. This user made a post. For a user and a tweet ID ka combination, they would have they have an index created, na, for user ID and tweet ID.
Okay.
So for a user, when you are iterating through it, you can go through that index one by one.
So like I'll be asking for first 20 and then if I reach around 15 or so,
Since this ID for this user, yeah, you will be having specified indexes for this use case. We'll be covering in social media wala series, so mostly next week we'll be discussing on how to do this very efficiently when you are building a feed like system. How can you structure your feed such that you would get a constant response time for each segment of it, similar to what we discussed today. So we discussed it on a global scale, like for all the tweets if I want to iterate. Now what if we want to do it for a certain user, like which is what you mentioned, like if for a certain thing when I'm scrolling. So just taking an example of Twitter. So let's say Twitter ka following wala relationship hai, right? And let's say I'm on my followers page. And when I'm on my followers page, I'm just doing scroll. Correct. So if I do limit offset there, after a certain time or after certain number of entries, my response time would be very slow, as we saw on those graphs. Correct. So now as a solution for that, what Twitter did, Twitter ensured that they have a constant response time for all the pages that they have, no matter where they are put. We will go through that structure and you can apply that same thing to this use case that you are saying if for a user's tweet come up.
Okay. Even same applies to YouTube. So they are also, so yeah, they'll also be doing the same thing, right?
But for in case of YouTube, there are not, even for thousands of users, it's still okay. The problem arises when you have more than 10,000 or 20,000 entries against one. That's when pagination starts taking a hit, or basically limit and offset starts taking a hit.
Okay.
So like, don't go into the company like immediately go ahead and we are doing pagination till 20, it's slow and let's just change it. No. For 100, 500, it means both the approaches are fairly same. The problem starts to pop up once we start hitting that scale. So like more than 10,000 case pay when you're iterating, that's when you start hitting that bottleneck. Your response time will shoot.
And moreover, they will be also not having any joins, right? I mean, it will be a straight.
Correct. Obviously, you would not have any joins for such use cases. Like for a user, if you are going through all the tweets, or for users, you are going through all the following lists, you would not have joins there.
Okay, thanks.
Right? Chala. Awesome. Any other question?
Arpit, I have questions around maybe how much of that clicks up with this. I'm not sure, but I'm just putting it up. So we talked about, writing data through DB, inserting something. But for some update operations, let's say we need to maintain this idempotency, right? So that that should not, maintain anything. So like, does that anything had to do with the ID generation that we went through today?
No. Why would idempotency play a part here?
For instance, the IDs are very the unique entry point to the system. So you would want to update something, you would want to refer to that particular ID, right?
So then the ID would always be, so in update, you would always give it the ID that needs to be, or the object, or the ID of the object that needs to be updated. Unless you have an ID, you will not be calling out update function.
I see. Okay.
Right. So no problem of idempotency there.
Okay. And the second one, maybe again a silly one too. So about the email IDs, right? Usually we have seen in the legacy systems, when we look for a particular email ID, it always quickly prompts that email ID is already taken or the ID is already taken.
Arey, nice.
So is that something, like how does this lookup happen so fast, and how does user get prompts out for this?
Chala. Anyone knows the answer to this? No?
It would be doing a query to the database, right?
Oh, that would be extremely slow.
Do they do prefetch query like Elastic?
No.
Or from the cache?
No. You would be putting all the email IDs in the cache, your cache would burn out. I will chat pe hoga
So if a user is having a particular email ID, right? Then it will, as someone already said, pre-calculate, right? What are the most obvious things?
No, because that's not how you should be building systems. Siddharth suggested regex. So regex is how you might match, but with this You're doing an exact match. So the question is, let's say a lot of people are trying to sign up or search on user ID. So the question is, we would want to check the availability of a username or an email ID in the system. How would we do it efficiently? So with regex, you might have that pattern to search for something, but with this, you are already given that complete email ID that you would want to check if it's present in the system or not. Chalo, I'll give the answer. I'll not go into the details of it. Read it on your own. Maja aayega. And then we would obviously, it's not about we'll not be covering it. We'll be covering it in the future one. But yeah, just a sneak peek around it. Check out Bloom filters. Someone knew this. Who was it?
Yeah, I knew Bloom, like I know Bloom filters, but I couldn't. Yeah.
What
we have
That's
used
not
Bloom.
what was expected now. See, this was a very straightforward problem, right?
Correct. Yeah.
So anytime you are doing a lookup like this, where you would want to check if something is taken or not, right? You can use Bloom filters. What Bloom filters does in just one line. If like in the context of Medium, so basically Medium uses Bloom filters to see, like another example is the post that you have already seen on Instagram. Instagram does not throw you the same post again, right? So how would it identify that you would have already seen this post? Correct. Similar to this, if you have read an article on Medium, Medium does not recommend the same article to you again. How would Medium do that? Like, just imagine like how much of data would I have to store to see that, array, this user has seen this user has seen this, and all of that part, right? To do this more efficiently, there is an approximate data structure called Bloom filters. What it does is it gives you a yes, right? So basically it gives you a yes, or sorry, let me put this simpler way. So it gives you a no, that a user has not seen this article if the user has definitely not seen this article. It will give you a yes, but that yes is conditional. So that yes will be an approximate. So if my Bloom filter says, yes, this user has seen this article, in actuality, that user might not have seen that article, or it might have seen that article, right? So it gives you false. So it would never give you false positive. That it would never give you it would never give you the situation where the user has seen the article and it would say the user has not seen the article. It would never give you this, right? Similar to this, like this can be applied over here. So if an email is definitely read, so it might be possible that an email that we are looking for might not be present in the system, but your system is still giving that this email is taken, right? So in case of GitHub username, let me give you another example with GitHub username. Let's say there is a username that you want on GitHub, but when you type on GitHub and you check for that username, it gives you 404. Like this is the case I'm talking about. Say GitHub would say that yes, username is taken, but indeed the username is vacant and you would receive a 404 when you are hitting that. So it would falsely say that a username is taken even when it is not. But if it says that username is taken, if the username is not taken, it definitely means that username is not taken. Correct. This is what it does, and it does this brilliantly, very efficiently with space, but it gives you approximation. So obviously you don't get guaranteed yes and no. You get a guaranteed no, or basically a very accurate no and a less accurate yes. But when you need a use case like this, where you need a very accurate no, but a partially accurate yes would work for you, you would use something called Bloom filter, which gives you very fast and very space efficiently. And it does using hashes. That's it. It just bluntly uses hashes to optimize this part. A very brilliant data structure. I've personally used it very heavily. Again, at Amazon, I've used it. Oh yeah, this was a brilliant optimization that we put in. So read that up. Bloom filters. So that is something that you should pay. So we will be covering Bloom filters a little bit, but it's okay. But it would be definitely great if you can give it a read. Yeah, Costo?
Okay, so one thing here, right? So if you want to scale up the servers, so like in the case of Postgres, we can just have extra logical auto generators. But like if we don't have the logical and physical partitioning, so how do you kind of get everything to stop, then scale up, or like how's
Also
that done?
downtime.
No option for that.
If you do not take downtime, then you would have to move a traffic to a certain database which can handle that much of load, add another database to it, and then move the traffic here.
Oh, okay.
Do the rolling part, right? Handle it on the application side and do the rolling part.
Oh, makes sense. Yeah, are there any other databases which have this kind of logical versus physical thing? Because that seems like
Mostly
a really
Cassandra. Yeah, mostly Cassandra has it.
that seems like a
And
very
definitely
neat.
Elasticsearch. Yeah, Elasticsearch.
Okay. Yeah, so basically, if you have to choose some MySQL database, this is like a very big plus point in for
Choosing
Postgres.
Postgres over MySQL, yes.
I mean,
so MySQL does not have logical shards. Postgres has it. Elasticsearch has it. Elasticsearch pay you can have like 5 shards on one machine, and let's say you had another machine in your cluster, and you can just change the shard. You click, but drag and drop this shard to this place, and the shard would be copied on that other machine. You
yeah.
can play around with that. So Elasticsearch is a great example of that as well.
Thanks.
Arpit, I have a question. Like you said, the 128-bit UIDs are they're a bit hard to store and index. So can you have similar problem with 64-bit IDs, or they are
64-bit is still okay because most of the languages do have 64-bit integer support. So if you can do it with 32, that's awesome. But with 32, you would not get that big of a space to play with. Right, because 2:32 is not that big of a number. It's just 4 billion something. Yeah, correct. Around basically around 4 billion. Right, it's not that big of a number. But if your use case is something that it's very hard for you to reach to that 4 billion point, then use that. Right, but if you are like Instagram pay 4 billion photos, तो ऐसे हो जाते हैं. Right, that is where you have to go for a 64-bit integer. Right? 64-bit 10 raised to power 19. That's much quicker. Like no one's ever going to hit that. But even though there, you said 64, it's obviously 64-bit integers. So with 64-bit representation, it's a little heavy on the index, obviously heavier than 32-bit. But again, gives you big enough space to play with. Any other question? Yeah, Vikas.
Yeah, so I'm asking like, is Bloom filter using any database call? Like
No. Bloom filter itself is a kind of a data structure, which holds the information in a certain way to make calls like this optimize.
Okay, so when a new user is creating their ID using their email, so at that time that email is getting stored in Bloom filter, like there
in the main database and again in Bloom filter.
Okay.
Right. So Bloom filter is a separate data structure. So you can implement it as normal binary blobs and store it however you want. So a typical storage pattern would be for each user, you might just have a binary blob against it in your database. And in that you are storing what all articles this user has read in a very limited space.
Okay, yeah, got it.
So it's just very space efficient. So you might not want to have like let's say if a user has read 1 million articles, you would not need 1 million elements long array to store that information. You might just need like a 10,000 or something to like approximate that part. So it's an approximation algorithm. Sure. Any other question? So question, but I thought all of you slept, and obviously today there are only 16 people. So yeah, I thought a lot of it was Sunday afternoon. Plus a lot of people might have slept off during this. But yeah, these are all interesting approaches. This is like just to help you guys understand the kind of hacks or the interesting things that these sort of companies or these sort of people do. Unfortunately, we don't have this big of an engineering culture here, right? I'm just trying to twist that thing. Chalo karte yaar, kuch majedar dekhte, and we just learn from them and try and apply hacks on the plates that we have. Right. So just trying to pose that. And obviously, this is a very interesting problem. Second cohort में one very fascinating thing happened. I took this lecture, this session happened, and there for one of the person, the interview was scheduled, and that interviewer asked him to design Twitter. Right? And obviously we discussed a few aspects of Twitter, but then he very smartly navigated the problem statement into saying ki, theek hai, with respect to Twitter, designing is still okay, but a bigger challenge for them is to like, how to deal with ID generation of these many tweets. So he just basically maneuvered the entire interview into direction of ID generation on Twitter, which we just covered. And he just did this thing and just maneuvered the entire interview and just got the offer the next day. And this was really fun on how we actually leverage something that we just very recently covered and just maneuvered the entire interview in that direction. Yeah, that's one story. I got really happy after that. Chala. Nice. If there are no questions, we can conclude. See you guys next week. If you have not logged in, please log into relog.in, learn.relog.in specifically. I'll be uploading the video there. I'll be sharing the link on the email anyways. I'll also upload the resources, the PDF notes, so that you can download it and annotate it if needed. So I'll do that. Okay. Thanks again, guys.
Yeah, Arpit, can we get your blog link on Cohort? Cohort, yeah, that.
Arpit, मैंने search करा आ जाता आजकल तो ऐसे हो गया. I'll just do that. But anyways, I'll do that. If you're not, do subscribe to my newsletter. Share. I used to share very interesting research paper-based stuff. You'd find a lot of interesting things. So at the end, I would anyway give you the list of things that you should be reading. That has helped me become a better designer of systems and all. So I'll definitely share those part. And just look out for Arpit Bani on Google and you'll find my blog there.
Okay.
Chala, awesome. Thanks.
Thank you. Bye-bye.
Bye-bye. See you next week, guys.
Thanks, everyone.